repair in from New York City. It's a handmade Archtop, about 30 years old, and it's a really nice instrument, but there was one sort of fatal flaw, and that is the tailpiece. The tailpiece is starting to structurally fail. We have to do three things. Number one, we have to dig into this tailpiece and figure out what is going wrong, and that will help us better understand how to redesign and re-engineer a new tailpiece that will prevent this failure from occurring in the future. The second thing is that I have to re-engineer a tailpiece that follows this same aesthetic so that it, respects the original design and the original builder of the instrument, and to just kind of follow the design elements in the guitar. We don't want to do something totally new because it won't look quite right. And then the third reason is because lacquer tends to amber over time, and when you have floating tailpieces, you'll end up with like a shadow on the top. So all of the lacquer around the tailpiece is dark, and then there's this light shadow that's been kind of burned into the top. And so if we deviate from this aesthetic design, you will see that shadow underneath whatever the new design is. And then the third phase is obviously to fabricate the new tailpiece. So this is going to be a multi-part video series throughout this process. I'm going to try to capture as much of it as I can, because I think it's an interesting thing to sort of see from A to Z, because it touches on structural design, aesthetic design, and where those two things merge. It touches on the load-bearing considerations of an Archtop tailpiece, and it touches on repair and restoration, and how repair and restoration makes us better builders, because something like this makes me think about my tailpieces, and B, how it's really important to have repair and restoration people operating in the field who also build instruments. I can tell from looking at this guitar, from tapping on the top and the back, that this is a really nice instrument. It's really well made, and the builder did a great job. We make mistakes, we don't always think things through, and that's just part of doing this. The goal here is not to shame anybody or anything like that. This is a really nice instrument, and I'll prove it to you when I get strings on it. This component just probably has some flaw in the design. So let's take it apart and see what's going on. If you can see these lines here, these are fracture lines that are coming with the grain, and they are coming from the load of the strings pulling on this here. Now the first thing I notice when looking at this is, well, first of all, I was surprised to see all this brass under here. When I got it off the guitar, I was sort of assuming that the brass probably stopped here and all of this was just floating ebony. So I was surprised to see the brass go all the way up in here. So we're gonna have to take this ebony cap off to see what's going on under this part. But one of the things that I noticed right off the bat was there's no brass where the ball ends of the strings are anchored. So what that means is that each ball end of the string is pushing, or rather pulling through this end grain, and there's no displacement of the load. Typically what I like to see on a tailpiece is that the strings are being anchored into some kind of substrate, usually like a brass bar. And what that does is it means that the ball end of the string, rather than being a point load, is kind of a displaced load across this whole area. So I want to use a nice chisel for this, because I don't know what's under here. I don't want to slam my chisel into brass. So I'm going to try to just get this cap off without having to rest apart. Okay, so what we have here is is a brass substrate that's pretty beefy down here, but then up in here where all your string load is, it got really, really thin, and it looks like I don't know what this is. It's like a bondo. It looks like that was used as a filler around the brass. So a couple things I'm seeing here. First of all, this brass is really too thin to hold all that string tension, and I'm not really sure if this is even doing anything, honestly. I mean, with a piece this thin, I'm not really convinced that this is doing more than just solid ebony would have done. So, and then the second compounding factor is that the channel was routed larger than the brass. So, you know, if you want the brass to displace that load, you need to have that brass tightly fitted in the wood so that whatever load is occurring is transferring through the brass, you know, across the grain, and then sort of being dispersed into the wood. If you think about it like a lamination, if you have bubbles in that lamination, then you're sort of defeating the purpose of the lamination. The whole point of a lamination is to have your compression and your stretching forces counteracting each other, and having each layer have a backing layer. If you have a bubble in that system, then you've negated those forces, and instead you have created actually like a weaker system than if you had just had a solid piece. Because now with this gap here, for example, you're really only relying on these two layers to do anything, because this layer has been separated from your system. And then the third problem I see is that it looks like this brass was laid into the ebony, and then the holes for the strings were drilled, and they actually drilled right through the brass. So, you know, not only do you have a very thin piece of brass, but you've actually drilled through the brass in at least two, it looks like 3 places. No, maybe 4 places actually. And so what this does is it completely negates the brass altogether, because now your point load is coming right through that severed area. And actually, I'm curious if, so here's where one piece was drilled through, and look at that, it falls right on a crack. Let's see, here's where another piece was drilled through. Let's see if that falls on a crack. Yep, right there, falls on a crack. The design itself isn't too bad, but it looks like the sequence of applications, or the sequence of assembly, was not thoroughly thought out. And the other interesting thing, it's not really a problem, but this area down here is massive in terms of brass. I mean, that's adding a lot of weight to this tailpiece right here. But this isn't really contributing to the strength of the tailpiece. You know, this is where you want your brass, right here and down these edges. But right here, it's not really doing anything. None of your tension is really centered right here on this brass. It's all, the load of the strings is being displaced by this piece of brass, and then it's being transferred down these arms by this brass. And, you know, this hinge, or you know, this angle here has some stresses on it, because that's where, you know, it's anchored to the guitar like this. You're pulling all this here, so there's some stress here, but not a whole lot up in here. So what we're gonna do is we're gonna re-engineer the brass piece, and we're going to rethink how to do this up here in a way that solves these, not only the load problem, but also the problem of sequencing. And then we're going to put a brass plate here to help displace that load. And I think that we can build a tailpiece that basically looks exactly like this, but we'll solve these issues. I'm surprised, to be honest, that this tailpiece lasted as long as it did. I think it was all this ebony piece. I think this ebony cap was holding the whole thing together. Let's hit the drawing board. Step 1 is done. Figuring out what went wrong. We know what went wrong. Step 2 is going to be re-engineering. That'll be the next video. If you like this video, let me know in the comments below. If you'd like to see more, please subscribe. And this is a different style of video that I'm trying out. It's a lot more work, so I would really appreciate the feedback, because I want to know if it's worth it or not. And once again, just as a reminder, none of this is meant at all in any way, shape, or form to shame or do anything negative to the builder of this instrument. I'm not going to disclose the brand or the name. If the builder's out there and recognizes his work, please write me if you have any issues with this. But this is purely education to get us all thinking about how to solve problems and how to design our instruments better and learn from each other. So, until next time.